people, doing how to build a simple family. First thing you do, click on your R button, New Family. Should automatically open to the template directory. If not, ours is under the R drive, Autodesk 2016, Family Templates, English. Yours is going to be under a similar folder if you're working off your C drive. A path is going to be close enough. So I always start my family as a specialty equipment. This gives you the most amount of flexibility. Moving forward, we will change that and we'll go through this. So on this project, I'm going to be drawing just a simple box, but it's going to be a representation of an air handling unit. So it's going to have a length, width, and a height that we've got to set. There's no connectors, no anything. We're just using it as a placeholder. So I figured this would be a really good family to do a little bit of a tutorial trial and error on this. So what we have is an AON heat recovery unit. Since we're just checking for sizes here, we're not going to get all crazy, put a lot of detail into it. We're just making a box. It's going to be 255 inches long, 105 inches wide, and 142 inches deep. And so the first thing you do is set up some planes. I'm just going to kind of throw them in here right now because you don't really know how big anything's going to be until you actually start applying some dimensions. So reference planes are the utmost important part of family building. All solids need to be tied to a reference plane to ensure that the dimensions are going to remain accurate. When you load them into a project and planes are not constrained and solids are not constrained to planes, you get whatever Revit decides to put in for a value, which may not be what you want, which is usually not what you want. So we're going to start out. The first thing I'm going to do is there's two planes you'll notice when you open any family. One is labeled as a center reference plane, front and back. The other is a left and right plane. You have to think of these as a vertical sheet of paper that you're going to be drawing on, because later on we're going to have to come back and reference these. And just for now, you can also label these as well. So we'll call this one left side. Doesn't really matter because they're only visible references for you to see while you're family building. They are not exposed in the actual project once they've been loaded. A couple other mentions about these things. You've got this is reference. This determines whether it becomes something that you can snap to inside of your project. A weak reference requires the tab key to be hit to be aligned to. A strong reference are the automatic, as soon as you hover over it, you see the reference line running through the middle of it. That's what we call a strong reference. The rest of these are, I don't know, the biggest option you'll probably use is either going to be not a reference, strong reference, or weak reference. These are going to be previously named stuff that we've already done. We're not going to mess with that. Usually leave them as weaks because there's a good chance that you want to snap to the edge of what we're making here, which is going to be an air handling unit. So then we'll throw some dimensions across this, and everybody should be familiar now with this guy. There's a couple of things we can do here. I am not going to get into parameters in this step because all we're trying to do is build a simple model. So in that case, we're going to end up with a couple of headaches if we try to use equal equal. Mainly, Revit won't let you do this. You cannot edit the linear dimension if you have an equal equal here. You can assign it to a parameter which will adjust it, but we'll discuss that later. So what I'm doing here, and the reason everything is based off this reference intersection, is because this is going to be the insertion point. I'm going to place the unit dead center of the crosshairs when you drop it on the screen, and I want to maintain that. If you wanted to have the unit to the left side, you would just start your modeling here and you'd work off to the right. first thing we're going to do is update these, and my unit is 255 inches long. Now there's a number of ways that I can put this in here, and I'm going to do the easiest because it requires me to not have to think. And it requires using an equation. I'm going to go equals 255 inches divided by 2. And there we go. So then, if you really want to be lazy, you can always do this. Copy, paste, and then there's also no harm, no foul to changing your units so it's familiar with the sheet that you're on. The one thing to keep in mind though when you do this, Revit does not maintain decimal accuracy. If you're set to the nearest 132 and you decided that you're going to switch this over to decimal, and since decimal is much more accurate, anything past a 32nd of an inch is going to be a randomized number. So generally you do not want to change this once you've gone forward working on a family. You want to change it at the beginning and leave it at what it's set as. Once it's loaded into the project, it assumes the project units, so there's no harm, no foul to drawing a unit completely in metric and then loading it into an imperial project, and the units will convert correctly for you. There's literally no math involved. So now that we've gotten to inches, we see that our 255 inch unit is now set. We'll do the same thing on the width. My number here is 142. Once again, I'm going to go equals 142 inches divided by 2. The reason I got that is because of the inch mark. You do, however, have to have it in the first part of the equation. Equals 142 inches divided by 2. If you're missing this symbol, it will fail. Prove me a liar this time around. So then this locks our constraint, and gives us a constraint for the width of the unit. Alright, and the reason I've got to switch these back to equal is it just maintains this distance and keeps everything 255 inches. At this point I'm going to go ahead and lock that dimension. I don't want it to ever adjust again based on any outside interference. I'm also going to lock the 142 foot as well. Basically, that gives us a rough outline of how big our box is going to be. So at this point, we can create an extrusion. I'm just going to use a rectangle because it, once again, less work. You see how all of our edges are highlighting on our reference planes, and then we see these padlock symbols appear. This is critical. You need to lock every object to a plane. I'm going to go ahead and cancel out and demonstrate a little more function. So when you align this to a reference plane, a lock will automatically appear. It will not do that if you move it. It needs to be snapped and aligned. So at this point, we have a box. That's all it took. Except we're missing something because boxes also have depth, and we don't want to let this thing just randomly choose how deep it's going to be. At this point, you have to go to another view. There's a couple different steps you could do. I mean, you could come in here and start and stop the extrusion. This is a method that will work, but if you're going to start looking forward into parametric objects, it is not a recommended method to learn. The best way to go is go to the plane that you need to be drawing on. You have to think of this as a 2D object, even though it's a 3D shape. Out of the box, when we go to the front view, again, we see our left-right reference. We also see a reference level, which is right here. And then there's also going to be a reference plane, which is one of the mini reference planes from our top view. Don't worry about it too much. The biggest thing to remember is that you want to attach to the reference level when you pull a dimension here. So I'm going to place another reference plane to be our top of the unit. And at this point, I need to tab because you can see the first thing that I'm getting is a shape handle. I want the reference level. This sets how far above the origin the solid is going to drive to. Over here, my unit is 105 inches tall. At this point, we're still not constrained, top or bottom. This is required on every family that in every direction these objects have to be locked to a plane. There's no ifs, ands, buts, or workarounds for this. If you don't lock it to a plane, you will not get the expected results that you're hoping for when the family is loaded into a project, and it is completely hit and miss. Um, I strive for accuracy. I strive for knowing that something is to be the size that I expect it to be. I don't want the software to assume what I'm thinking. We all know that that doesn't work that well. So at this point, we've created a box, and it's locked down to planes. We're all good to go. Except of our object classification. If you remember that when we started this, it was a specialty equipment item. We need to change that. This is a mechanical unit, so I'm going to assign it to the category of mechanical equipment. Later on, when we get into connectors and stuff, we'll have to come back in here and interact with more of the dialogue, but that will be coming much, much later at this phase of the game. So at this point, we've got our little unit. Let's just give it a little bit of information for the person that's going to be using it. Mainly, I want to give it a name, and the type name is going to be shown here. If you don't give it one, it's just blank. It inherits the family name when it's loaded into the project, but we can be a little bit more descriptive than that. Revit gives us that option, so we're going to call this Aeon RN Series HRU. We don't have much information, so this is what we're going to supply. This is just for check and space requirements, so we're not putting a lot of detail into it. You could also, these are stock fields out of Revit, identity data, but we don't really use these inside our network. You might use them inside of yours. This is optional. So save this guy. You probably work off your desktop or whatever you do. I've got a very cumbersome directory structure, or I don't know what you want to call it. So the last thing we want to do, and I highly suggest doing this in a separate session than the session of Revit that you're working out of your project in, because if you have any problems with this family, it may crash your model. It won't take it down with no recovery, but you'll end up spending 20 minutes restarting everything again. So I'm just going to go back to my family. I'm going to load it into my new test project, which is project 1. Because we have a cover page, you always get that error. Drop it in here. Alright, let's see how big she is. 21 foot 3, which happens to be 255 inches, by 11 foot 10, which happens to be 142 inches. Come over to our submittal sheet again. 142 inches by 255 inches. Last thing we want to do is draw a section and make sure our depth is good. Foot 9, which is 105 inches. exactly what we want for a height. Hopefully this helps, and maybe you learned something, maybe you didn't. Thank you very much.